chapter 5, number 1. What's the difference between, oh, who's got the, Stephen, so you're the next question, right? Because
No, I gave it to him. He's the first question. It's all.
so we pass and then answer, right? Isn't that the way we work?
I thought it started.
That's okay. That's okay. That's fine. The first one's easier, Stephen. Thank you for blessing it. Give it back to Starnes. Okay. So what's the difference between ions that you've learned about previously and the ions that we learned about in this module? Pretty straightforward question. So.
I said ions that are formed when a group of atoms gains or loses electrons. That's not right.
Okay. That's unique to this chapter, right? Because the ions we learned about previously were all based on single atoms. Okay, so it was an ion, it was a calcium ion, it was a sulfur ion, it was a fluorine ion, fluoride, it was a bromine ion, bromide. This module, we actually came with the polyatomic ions. Polyatomic means many atoms, or more than several atoms. So multiple atoms coming together to form, it says more than one molecule, it should say more than one atom. Okay, it's a typo. But these ions are actually groups of atoms that form by covalent bonding. They come together and form not a molecule but an ion, so they have a net charge. They're held together covalently, yet they have a net charge, meaning when they bond with something else, they bond with it ionically. So it's a covalent, you might want to call it structure, submolecule, that's going to bond with another ion and bond ionically. So that's the difference. Number 2. Okay, so there's chemical formulas and then their charges. This should be pretty much like popcorn. So sulfate is
SO4
2 negative, right? Okay. Do you just want to knock them off? Since you've got your homework right there, right? Your best guess. You guys can see if you're right or wrong. So next is chlorite.
Okay, so I got ClO2 negative.
Okay. It's chlorite. So what would chlorate be? No, formula-wise, what would it be? Just, we got ites and eights, right? So an ite has more or less than an eight. Eights have more than ites, so we can't go less than 1 oxygen, right? So it's going to be a ClO2 probably for chlorate. The next one they asked for is acetate.
C2H3O2
Negative 1. And a sulfide.
And then they got sulfide with SO3 2 negative.
It's not a polyatomic ion, is it? It's an ion of sulfur, sulfide. It's not a sulfite, it's a sulfide. So everyone has been off the table except for this one, table 5.1. But a sulfide is a ion of sulfur. It's a S2 negative because it's a column 6 element. Dichromate.
CR2O7 2 negative.
2 negative. Remember, dichromate and chromate have the same charge. They're both 2 negative. Chromate is a CrO4 2 negative. Dichromate is a CR2O7 2 negative. Dichromate is almost double of, except for the oxygen, right? It goes from Cr, implied 1, goes to Cr2. O4, double that would be O8, but it's short of that, O7. That's how I remember it. So dichromate means 2. Cr2O7, but it still has the same charge, 2 negative, as a chromate. So chromate and dichromate have the same net charge. Okay, and again, every one of those is memorized off the table except for the sulfide, which you had to remember is just an ion of an atom. Oh, one more. Forgot about that one. Phosphate.
PO4 negative 3.
PO4 3 negative, right? Okay. See how fast this is going? You know how much work it took me to do those few minutes worth of class? Here we go. 503. Give the names of the following ions. So we give you the ion. Give us the name of NO2. Trite, right, nitrite. So nitrate was probably going to be NO3, right? Because trites have less than traits, traits have more. So it wouldn't be NO, that's a, right? But it would be NO3.
I guessed on this one.
Go ahead.
I just put nitrite.
The O? 2 negative? Okay. Yeah. It's not a polyatomic ion. It's oxygen. What does oxygen oxidize to become? What does it ionize to become? Oxide. Right? The iod name of oxygen is oxide. Chlorate. So chlorite would be, since 8s have more, it would be no. CO3. Carbonate. And SO3. Sulfite. So what's sulfate? SO4. 8s have more than ites. Is there another one? Oh, got it backwards. So there's your chromate. Remember, dichromate, Cr2O7, 2 negative. Practice problem number 1. Let's do one at a time on these. You can pass for each one of them. Gives more people a chance. Right? Since these aren't straight from the chart, these are actually doing a little bit of thinking to come up with the formulas. Potassium sulfite. What do we have for that?
K2SO3.
Potassium sulfite. Okay. Any questions on how she came up with the formula? The K2SO3? Since there's no questions, let me just go ahead and repeat it then. Potassium has an ionization, or a net charge when it ionizes, of +1. Sulfite has a charge of 2 negative, so it takes 2 potassiums to balance out the 1 sulfite. Right? Next, beryllium nitrate. Nitrite would be, but nitrate is 3, so. But beryllium nitrate. So you're correct in the beryllium. It has a, what's the net charge here of beryllium? What's its charge when it ionizes? Okay. So what's a nitrate have as its charge? Pardon? Okay, if nitrate has a 1 negative, beryllium has a 2 positive, right? Let's check it. Beryllium's right here, column 2A element, so it goes to a 2 positive as a metal. So it takes 2 of the nitrates to balance out 1 of the berylliums. That's how we get that formula. Manganese 4 carbonate. Gave him an easy one.
Mn2CO34.
How do we come up with that?
Oh, okay. It's not.
What did you have again?
I had Mn2CO34.
No. Because it's an ionic, right? So you need to reduce the greatest common factor between the subscripts, right? So Mn2CO3 sub 4 means you've got 2 manganese and 4 carbonates, which reduces down to 1 manganese and 2 carbonates. Okay, so your proportions were correct, but you didn't reduce to the greatest by the greatest common factor. So MnCO3 sub 2. And aluminum chromate. Where's it at? Where'd it come from? Oh, cut it off a little bit, didn't it? Al2CrO4 sub 3 it has. How do we come up with that? Aluminum is a column 3A element. It goes with a positive 3 when it ionizes, right? So it's 3 plus. Chromate has a 2 negative. So does dichromate, right? So again, you just transpose, dropping the signs. So if you think about it, 2 at 3 positive is 6 positive, and 3 at 2 negative is 6 negative. They're equal and opposite. Practice problem 2. Give the names for the following compounds. So we're going to work the other direction. Okay, so ammonium dioxide. If I have my eyes closed, ammonium dioxide, the di, does it go to the ammonium or to the oxygen? When I say dioxide, it would be the oxygen, right? So that would be NH4O2, ammonium dioxide. That's not what we have here. This is just simply ammonium oxide. Okay? And you don't have the dyes because these are ionic formulas or ionic molecules. So it's always going to be the ionic naming paradigm. So even if there were NH4O2, that would reduce down to NH4O. Okay? But if you find yourself in a case where you have let's say it was an NH4O2, it would not be ammonium dioxide. It would just be ammonium oxide in that case as well, because these are ionic molecules. Though they have a covalent molecular portion, they're named according to the ionic compound. This is an ionic compound. And within that ionic compound, it has a covalent structure. But it is an ionic molecule, so it gets an ionic name. Okay? RbNO2. Rubidium nitrite. And you see in here, there's the rubidium, and there's my nitrate. ZN3, PO42.
Molly, you gone yet?
Zinc phosphate. What if I told you I need more information than that? A little bit more information. It's not simply zinc phosphate, because zinc is what kind of a metal? It's a transition, right? So we're going to have more information. Zinc can have more than one ionic form. Okay. So what is the charge of a phosphate? Pardon? 3 negative, okay. And we have how many of them? 2, right? We have 2 phosphates. Each phosphate is 3 negative. If I have 2 of them, I then have 6 negative charges, right? So I've got to balance out a negative 6. Now I've got to balance it out with the charge of the zinc, and I've got 3 of them. 3 of them has to equal positive 6. So each one of them has to be, if I've got 3 of them and they have to total 6, then each one is worth 2. That's why it's zinc 2 phosphate. Zinc could have more than one charge. So if zinc ionizes to be a +2, and I have 3 of them, then I have a +6 charge to balance out 2 of my -3s to be a -6 charge. Okay. So zinc phosphate is close, but zinc 2 phosphate is the correct answer. And anybody not had it yet? I don't think so, but okay. Cobalt 3 phosphate, another transition metal, right? So phosphate, again, has a 3 negative charge, and 1 cobalt balances that out, so cobalt has to have a 3 positive charge. Why it's cobalt 3 phosphate. Okay. Practice problem number 3. It says, give the chemical formula for each compound in the reaction. So this is where we look at all the different compounds. Like, we have 2 reactants that produce 2 products. So the reaction is calcium nitrate reacts with sodium carbonate to produce solid calcium carbonate and sodium nitrate. Okay, so let's just walk through it. First one, calcium nitrate. Suck it to me.
CaNO3.
Close. Close, right? So a nitrate has Think about that for a minute. Is that right? What's a nitrate? What's the charge of a nitrate? Anybody got table 5.1 in front of them? What's it say? 3? You sure? Really? Are you guessing? Does it?
Yes.
Well, if it has a 3 negative, we got 2 of them, we got to balance out 6 with a calcium? Is that right? Let's walk through calcium nitrate. Okay, if you need to, table 5.1, if you don't remember. If we open up to table 5.1, the nitrate, excuse me, is an NO3, 1 negative. Okay, so it's got a charge of -1. I have 2 of them, so I have -2, right? I've got 2 negative from the 2 nitrates, and calcium is a column 2A element, so that makes sense. I've got a 2 positive, and I need 2 at 1 negative each to balance that out. So that's my calcium nitrate. The next reactant they had was sodium carbonate. No, we'll pass them around. So a carbonate is, oh, go ahead. And what's the formula you had? Okay. So carbonate has a 2 negative charge. Sodium has a +1 charge. So it takes 2 of them to balance out the 2 negative, right? So calcium nitrate, sodium carbonate. The third one, calcium carbonate. Okay. Calcium is Ca. Carbonate already has a 2 negative charge, right? And calcium is a 2 positive charge. So it takes 1 of each to balance it out. Calcium carbonate. The last one is sodium nitrate. Yep. Sodium +1, nitrate to -1. Now, notice what's happening here in the reaction. The only thing that's happening is let's look at the metals first, okay? Calcium, sodium, right? The issue is not what do we have, but what is it paired with? Here we have calcium and nitrate. Here we have calcium and carbonate. Here we have sodium carbonate, and here we have sodium and nitrate. So what's happening? The 2 metals, the 2 compounds that are reacting, you can think of it this way. The 2 metals are just swapping ions. The calcium nitrate and the sodium carbonate come together, and sodium says, I would rather have nitrate, and calcium says, I would rather have carbonate. That's why it looks like this. Okay? And like I said before, bonus information. Okay? Bonus for your further education. This is bonus material. But like when we did this the first time in class, we can't create or destroy anything, right? All we do is rearrange it. We can't break up the building blocks past the elemental form. And matter of fact, in this case, we don't even break up the polyatomic ions. All they do is swap around. Because I have nitrates and carbonates. They just change who they're partnered with. They're at a dance and they switch partners. That's all that's happened here in this reaction. But let's notice something. Since we can't create or destroy anything, all we can do is rearrange it. Let's take a quick look to make sure that we have what's called a balanced reaction equation. In other words, if I take 1 molecule and 1 molecule and I react them, am I going to create 1 molecule and 1 molecule? And I can determine that by looking at how many of each atom I have. How many calciums are on the left side of the arrow? Take a quick look. How many do you see? Survey says 1. Good. Wir werden nur auf Englisch sprechen, bitte. Okay, so calcium, that was me being ironic because I said we're only going to speak English. But I said it in German. That's the irony. Okay, so we've got 1 calcium on the left and 1 calcium on the right. Good. What's next? Nitrate. How many do we have on the left? We have 2 of them, correct? How many do we have on the right? Survey says, wait, when I do that, you give me your answers. That's the deal. Okay, so how many nitrates are on the right? Survey says, okay, we'll try it again. Think harder, harder. Okay, looking at what's on the board, how many nitrates are on the right-hand side of the reaction arrow? Survey says 1, right? How many did we have? 2. How many do we need to have? 2. If we're to be balanced, what I'm saying here is if I leave it just the way it is, I have destroyed a nitrate. I just threw it. I didn't throw it away. I obliterated it. It existed, and I said, it's gone. It now no longer exists. I can't do that. I don't have that authority. Okay. I say I start with 2 sodiums. How many do I have on the right? Survey says 1. I have 1. Look it. I've got 1 sodium. Here I have 2 sodiums. What have I just done? I've destroyed a sodium. I don't have that authority. All I can do is rearrange. I can't create or destroy. So how do we reconcile this? We're going to learn in an upcoming module pretty quickly here that all I do is go ahead and add a 2 in front of sodium nitrate. Now let's look at it. How many calciums do I have? 1, 1. Nitrate, 2. 2 at 1 is 2. Sodiums, 2, 2. Carbonate, 1, 1. It's balanced. What this is telling me is if I take 1 molecule of calcium nitrate and 1 molecule of sodium carbonate and react them, I'm going to produce 1 molecule of calcium carbonate and 2 molecules of sodium nitrate. I haven't created anything. I've rearranged it from 2 molecules into 3. But I haven't created or destroyed anything. Okay? That's why it's bonus information, because it's here to make you go, whoa, but it's not going to be on the test. Extra practice problem number 1. Give the chemical formulas for the following compounds. Lithium sulfite. Same old stuff, just different ones. Lithium sulfite. Yep, Li2SO3. Next is ammonium phosphate. We've only got a couple moments here. Ammonium phosphate.
NH3PO4.
Ammonium has a positive 1 charge, phosphate has a negative 3 charge. I need 3 at +1 to balance 1 at negative 3. Okay. Calcium carbonate. Okay, pass it. CaCO3. Okay, there you go, calcium carbonate. Because carbonate has a 2 negative, calcium ionizes a 2 positive. And don't know it, that's not a good reason not to try. Wrong. See, I don't even have to hear her. She's wrong because she said she's wrong. I believe her. But let's give it a shot anyway, okay? Aluminum dichromate. Good thing I didn't believe you, right?